King here.
Father in heaven, we are indeed thankful for the privilege we have to be here on this Saturday to help strengthen our faith, to grow in our knowledge of Thee, Father, and to equip ourselves better to answer the challenges of those who know not Thee and know not Thy Word. Father, we are thankful for Brother Peyton and for his studies, for his efforts, for his willingness to serve in Thy kingdom and to labor for Thee. We pray that You will bless him with long life and many opportunities to do the good that he is doing, Father, that souls may be saved through his efforts. Father, as we consider this hour the geological evidence for the flood, we pray, Father, that we will examine those things, that we will be strengthened and encouraged in our faith. And again, Father, may we be assured that Thou art the God of the Bible, Thou art our God. And Father, as we are encouraged by the fact that we know that Thou art, we are encouraged by the promises that Thou hast made of heaven and of the hope that we have to be there if we live faithfully unto Thee. Father, we pray that we will be able to remember the things that we study. We pray for Thy continued patience and long-suffering and allowing us time to teach these things to others. It's in Jesus' name we pray. Amen.
I believe this is the most challenging lesson of the entire weekend because we have to do it right after lunch. When I imagine you are like me, I'd like to rather take a nap. Rick said I can answer any question that you ask. From Rick's perspective, that is, if I don't know, that is a sufficient answer. And so since he's passed out all these pink slips, I suspect we'll have many questions, but I will do my best when that time comes. In this lesson, we're going to talk about Noah and the flood. You don't get many children's books that talk about Noah and the flood. There's been cartoons and whatnot that have drawn. Every time I see these books, I always see all these happy animals smiling, and you see Noah and his family, everyone's waving, and it's like a big floating zoo. And I believe that if we start with the biblical data, we come away with a much more sobering understanding of God's view towards sin, His wrath against mankind because of that sin. And we understand that this was not a happy time, rather it was very sad and sobering. So geological evidence for the Genesis flood. We'll start with Joshua chapter 4, verses 1 through 6. We read the following. And it came to pass when all the people had completely crossed over the Jordan that the Lord spoke to Joshua, saying, Take for yourselves 12 men from the people, one man from every tribe, and command them, saying, Take for yourselves 12 stones from here out of the midst of the Jordan. From the place where the priest's feet stood firm, you shall carry them over with you and leave them in the lodging place where you lodge tonight. Why? Why are you taking these 12 stones? That this may be a sign among you when your children ask in time to come, saying, What do these stones mean to you? I have been to some of our nation's most popular national parks out in the Midwest, and I've gone there with fellow Christian friends, and it astounds me that we can be surrounded by the beauty and majesty of God's creation, yet very few people, when they go to these places, will stop and ask the question, how did these rocks get here? What do these rocks mean? And I hope after today's lesson, you'll walk away with a different understanding, perhaps appreciation for those monuments, for those markers that I believe God has left for us as a testament to his wrath and judgment towards sin, as a testament to the global flood that changed this landscape forever. First, we'll go through a brief history of geological thought. I want to go back to that conversation on observational versus historical science, but put it in the perspective of geology. Then we're going to go through 10 geological evidences for the global flood. So again, with a brief history of geological thought, we've already touched on several of these things, the difference between concordism versus non-concordism. And we showed from Scripture that whatever God spoke into existence in creation should match what God wrote through written revelation. That the two are from the same source of truth, therefore the truth properly understood should come together and coincide without contradiction. And we also discussed that for a long time, geology and other scientific disciplines were founded by people who believed in God, believed in the Bible, and they actually viewed their work as following God's handiwork, understanding God's creation. And it wasn't until the Enlightenment that we started to have theories like naturalism, where they start to try to explain the world without God. Men like George Louis Leclerc, who introduced the idea that the earth was formed over 75,000 years rather than the thousands of years we get from Genesis. And this departure has continued through today. And one of these ideas that came out of the Enlightenment was this idea of uniformitarianism, which we know James Hutton came up with and Charles Lyell popularized, bringing us to this modern thought of the earth being 4.6 billion years old, the universe about 13.7 billion years, dinosaurs living 250 million years ago, and the first signs of life occurring around the Cambrian, around 500 million years ago. So let's put this uniformitarianism framework into geology, because we mentioned there is observational science and there is historical science. In observational science, it doesn't matter what you believe in terms of origins. And you can build a car, a battery, an engine. What you think about the age of evolution has no bearing on that. We also talked about forensic science and how it's always trying to put together a puzzle. We don't necessarily have all the pieces, and so assumptions have to be made. How does that relate to geology? Well, one of our national parks, Guadalupe Mountains National Park on the border of Texas and New Mexico, there is a cap rock in that mountain range called El Capitan. It's a limestone reef rock. It has many shells, and so imagine we walked up to El Capitan and we look down on the ground and we find this fossiliferous limestone. And we ask the question, what can we observe about this rock? Well, it turns out it doesn't matter if you're an evolutionist or a creationist, you're going to get the same answer if we describe the color. If we measure the grain size or describe the rock type, if we try to understand how much empty pore space is in the rock, we describe the fossils, we see there's some clams, some bivalves scattered throughout. We look at how hard the rock is, what type of streak color it produces. We may even measure how easily fluids can move through this rock to see if it would be a good rock to store hydrocarbons. We can measure the density. So observational geology, or sometimes called physical geology, is all about describing what kind of rock this is and where this rock is at. As it turns out, that is actually the majority of what geologists do. But if you take geology classes in college, this is the first class you take. The second is called historical geology. And that's all about answering questions like, how old is this rock? Where was this rock originally deposited? How did it get here? What's happened to it along the way? And what I have never seen in the field is a rock that comes with a tag that tells me all that information. Rather, that is information that must be inferred or assumed. So how do geologists figure that information out? Well, if you're going to study limestones, that is a carbonate rock. In carbonate rocks today, if we're going to study the present to figure out the past, you might go somewhere like Turks and Caicos. Probably a pretty good place if you want to go study geology. And you're going to develop a model. You're going to see that there is a beach area where you're going to get some sands. You're going to notice the grain tide and maybe what type of animals live in that part of the island. You'll notice that as you go out, you'll get into a more lagoonal environment. It'll get a little bit muddier. There'll be some other animals that live in that part of the lagoon. And eventually you'll come to a barrier reef. And then it will drop off and get into some deep ocean. And they'll create a model. Let's say this is a carbonate platform model. Here are the grain structures and rock types that I see in the present. Now I'm going to go look at all these rocks and outcrops, places like Grand Canyon, Zion National Park, and elsewhere. And I'm going to try to match that up with the present day model that I see. Again, the problem I have with this is that we're assuming the present is the key to the past. But if the past had events that are no longer happening in the present, how can I study to know that that's going to match up? Rather, I believe the past is the key to the present. If we know past events happened, and we have those coming into our models in the present, then I believe we can have correct models that align with the data. So that's the difference between observational and historical science, particularly as it pertains to geology. So what I want to do now is look at the geological evidence with that framework in mind and ask the question, does it fit the narrative of gradual, slow processes over millions of years? Or does the evidence point to catastrophic, large-scale events happening in short periods of time? We're going to go through 10 evidences. Maybe a little bit longer this session, but we'll cut it down a little bit in the following session. Evidence number 1, marine fossils high above sea level. Let's start with the biblical data. Genesis chapter 7, beginning in verse 17. We read, "Now the flood was on the earth 40 days. The water increased and lifted up the ark, and it rose high above the earth. The waters prevailed and greatly increased on the earth. And the ark moved about on the surface of the water. And the water prevailed exceedingly on the earth, and all the high hills of the whole heaven were covered. The waters prevailed 15 cubits upward, and the mountains were covered." So we ask the question, where should we find marine fossils? If the flood covered the entire earth, would it not make sense that we find marine fossils all over the earth? We should find them in the high points. We should find them in the low points. More importantly, we should find them in the interiors of the continents. And that's exactly what we find. Whether it is marine clams, brachiopods, bivalves, or ammonites that are the shells of squids, or trilobites, or sea stars, we find all of these marine critters scattered all over the continents, all over the land, everywhere. And even secular geologists don't have a problem with this. They admit this, and in their models will admit that all of the Earth's surface was covered with water at least at some point. For example, if you go to Grand Canyon, which is approximately 7,000 to 8,000 feet above sea level today, you will find in the rim rock there, the Kababa limestone, brachiopods, these little clams that we know come from a marine setting. So this was a marine deposited rock, if that is in the interior of the continent. You also can go to our world's tallest mountain range, the Himalayas. And in this mountain range, go to the top, you will find ammonites, coiled cephalopods, that is squids. They used to live in these shells and swim around. Now some make a mistake here, and they assume that because we find marine fossils high up in mountain ranges, that's how high the floodwaters rose. But actually, and we'll explain this more later, we had continents breaking apart. We had continents colliding together. And we had the mountain ranges forming. And so in the case of the Himalayas, I have the Indian plate slanting into that continent and submerging and pushing up this layer of rock. And so the reason we don't want to make the mistake of putting where the flood had to be height-wise way up here in our tallest mountain ranges, that may require us to put more water on this planet than is actually here. So we need to be careful of that and not make wrong inferences. But what is still impressive is the interior in which these marine fossils are deposited. And so what can we conclude from all this? We conclude, number one, that the Earth must have been covered by the ocean at some point. The question of difference between the creation and the evolutionists on this is, was it covered by water at the same time? Or were there different parts of the world that were covered with water while other parts were dry? And that's what the secularists would try and argue. What else can we learn from the fossils? In what state do we find the fossils today? In what state would we expect them when starting with the biblical data? Again, going back to Genesis chapter 7, beginning verse 21. And all flesh died that moved on the earth. Birds and cattle and beasts and every creeping thing that creeps on the earth, and every man. All in whose nostrils was the breath of the Spirit of life. All that was on the dry land died. So we destroyed all living things which were on the face of the ground, both man and cattle. So if everything died and everything was buried, what should we expect to find in the rock record? Well, we should expect to find literally quadrillions, maybe quintillions of dead things that have been killed and buried and preserved for us to find today. And we should find them in all states. We should find things that were active. We should find things that were buried in more chaotic states. There should be all flavors of burial. And in fact, that's exactly what we find. For example, if you go to Colorado, there is a formation outside of Florissant, Colorado called the Florissant Formation. And in that formation, you will find insects and freshwater mollusks. You will find hundreds of plant species and birds all buried together. Well, that's exactly what I'd expect to find. We expect to find marine mixed with non-marine mixed with terrestrial fossils if a global flood covered the entire planet. I would also expect to see things that are preserved rapidly. I have a couple of examples here you're welcome to come and look at. I'll give a brief explanation of some of them. This is a leaf. This comes out of Montana. And what you notice on the leaf is you can see all the edges, everything, it's well preserved. But when fall hits and the leaves start to fall, what happens? Do they just hang around for very long? No, they dry out. They become very brittle and they break. So how are we able to preserve a leaf like this? Well, it would have to have still been wet. It would have been fresh off the tree and then rapidly covered and buried. So that's evidence of rapid deposition. Another example I have here, one of my favorites, this one comes from the Green River Formation in Montana. This is a deposit that's actually supposed to, understood actually formed after the flood. But I have a fossilized fly. Now you cannot see it from where you're sitting, but make sure you come and check it out. But you'll see its wings, its body preserved. If you've ever been swatting flies in the summer, what happens to them? They die and fall next day, you don't see them. Something comes along and eats them. And so it's very difficult to preserve many of these animals. I have another one here. This is also Green River. It's several small fish. And what you'll notice is they're kind of captured in a more chaotic state, probably caught in some sort of little whirlpool and preserved. And if you look at the sides of this little plate, there's layers to this. And the secularists believe that these layers take about 1,000 years, 100 years for each one to slowly accumulate on the bottom of a lake bed. But if you look at the back of this fossil, you notice there's more fish, which shows you can get many fish being laid down, all these layers created in a very short period of time. Also have a shale. This shale comes from Utah, and in it you'll see many trilobites. These are little marine critters, kind of like little cockroaches that ran around on the seafloor. And what you'll see is they're all broken up, preserved in different orientations and fragmented, because some parts of the flood would have been very violent, and they would have destroyed and killed. But at the same time, other parts would have been calmer. If you've ever been around rivers, rafting, with the rapids, you'll notice there are pools that get created that are very calm. There's other parts that are very violent. Same would have been true on a global scale. Here's another trilobite that is well preserved. It's actually two trilobites preserved in two different orientations. This one comes from Morocco. Excuse me, another one over here from New York. Let me show you some more examples that just show this preservation. Here we have a fish that has choked on another fish and been preserved. In fact, these are called aspirations. They're more common than you might think. Almost had the chance to buy one of these for a quick $6,000 or so up in Nevada. But I used to think that was a fish swallowing other fish and then that moment being preserved. I actually think this is fish choking on other fish. If you look this up on YouTube or Google, it's more common than you might realize, where a fish tries to swallow a fish that's just too big to fit in their mouth. Here's two videos where this was captured. First one's a catfish trying to swallow, I think, a bass. Second one is a bass swallowing another bass that actually was in Texas or in the Austin area. And what you notice is those fish are located where? The top of the water. What happens when a fish dies? It floats to the top. And then a bird or something will come by and eat it. They don't last very long. Even bones on the bottom, they don't last very long. There's critters down there that will come around and eat them. And so in order to preserve this, we have to have an environment that can rapidly preserve and bury those animals. Here's another example. This is two different examples, but the same scenario. These are ichthyosaur dinosaurs who were preserved while giving birth. The top one comes from Germany. It had several babies still present in the womb with one in the birth canal. And the bottom was discovered in China, and it has three as well, one inside, one outside, and one in the birth canal. Again, if a cow or something passed away today and we found them dead in this state, what's going to happen? Someone's going to come by, a buzzard's going to clean it up and eat it really fast. You can't just leave things like this laying around for very long. Another really interesting fossils, this is known as the fighting dinosaurs, dueling dinosaurs, was discovered in the Gobi Desert of Mongolia. You have a velociraptor and a protoceratops literally locked in battle together with the velociraptor's arm in the protoceratops' mouth while they're fighting. This one comes from Japan. It's actually a museum there. And it's a school of fish. And even when the secularists examined this, they noted that this was preserved exactly like you would find a school of fish, small school of fish swimming together today. Because what small schools of fish do is they use the propulsion from each other to be able to swim in a large ball. We call them bait balls sometimes. And they were swimming exactly as we see swimming in the modern day environment. Now, another interesting about these fossils is that when we go to the lower layers, where we find the trilobite fossils, for example, we actually find their little footprints before we find their actual bodies. And so Dr. Kurt Wise, he noticed the pollen when he was out searching for these in Death Valley. He said, I was excited. Scampering up a remote hill near Death Valley, I finally had an opportunity to visit one of the only dozen or so places in the world where you can find the lowest layer of animal fossils. Starting near the car, I scoured up the ground very carefully looking for fossils. After examining one layer, I would search the layer above it, slowly working through higher and higher rocks. The flaky shell rocks were the kind that preserved fossils well, so I was sure I would find something. At long last, I found a trilobite trackway. The only fossil I found in that layer. In the next layer, I found several more tracks with no remains of the trilobites themselves. As I went up, the tracks became more abundant. But I found not the slightest hint of the animals that made the tracks. Then suddenly I came to a layer jam-packed with trilobite shells. I had been so concentrating so hard on finding just one little fragment of trilobite, the abundance startled me. Why would dozens of feet of rock have tracks, but not the animals that made them? The finding is especially mysterious if you believe the rock was deposited over thousands of years. Interestingly enough, the site is not unique. Tracks are found before trilobites everywhere that the lowest trilobite layers are known. Such a worldwide pattern of fossil layers suggests that a global catastrophe such as the Bible describes once struck the world. The photo up there on the top right, I've actually seen those trackways in person. there in the Grand Canyon. But you will find these where you see animals walking along and all of a sudden, boom, they die. Trackways are preserved. And you think about the events of the flood. All these animals are happy, everything's going well. And all of a sudden, a big tsunami-like event comes over them, they're going to get disturbed. Where are they going to run? Probably up, trying to escape whatever's coming. And so they're going to leave behind tracks that are going to get buried first, but eventually they're going to get captured, and we'll see their remains preserved as well. Here's a group of trilobites playing follow the leader, as it's been described. This was found in part of Morocco. Again, even evolutionists admitted that this was a storm-like deposit. But we also find these mass mortality plates. As it pertains to dinosaurs, we find dinosaur graveyards, where you see large amounts of these fossils all destroyed and buried together at once, all different orientations, shapes, broken apart. It speaks to the diversity in which we find these fossils, but it is also what we would expect if we had a global flood. This is the Zertis trackway. It's more a model of it found in the Natural History Museum in Houston. And what you see here, there's about 14 or so different animals that they all have their tracks preserved here. Everything from birds to dinosaurs. And this is the type of environment I would expect during a flood. You think around the watering hole cattle. Does it take very long for those footprints after it's rained or something to dry out and quickly vanish away? It doesn't take very long. But if you had a bunch of animals in a very wet environment, it's chaotic, they're going all different directions, this is exactly what I would expect to find as a result of the global flood. There's another fossil of horseshoe crab that comes from the Museum of Natural Science in Houston. You can see it's walking around, all of a sudden it does a quick 180, and if you look right before it dies and is buried, it kind of struggles, scurries a little bit there at the end. But of course, you may ask this, the question becomes, well, how do you make a fossil? What are the requirements to make a fossil? There are several different ways you can make a fossil. You can preserve the original part of the fossil. You can preserve an imprint of the fossil. You can have the fossil recrystallize. But as it turns out, there's two primary ingredients, heat and pressure. What is often assumed is we need millions of years to do this. But what I'm showing you there on the screen are all fossils that were made in a laboratory. Didn't take them millions of years. It just took enough heat and pressure in order to produce them. You can see the before and after. Here's the head of a lizard, and there's the after. Looks very much like what we find in the rock record today. Time was not the issue. And so I joked with some of the brothers before. I have with me here what I believe is a fossilized battery. Of course, the evolutionists would have trouble saying that that's millions of years old. I had another geologist who looked at it, and that's also what they concluded it to be. But I don't have any firm testing on that to prove it, and it does match the shape, size, and dimensions of a typical AA battery. Out-of-place fossils. We mentioned we would see the mixing of marine and non-marine fossils. That's exactly what we find in coal mines in France. We see hagfish, ray fin fish mixed with amphibians, mixed with spiders, scorpions, millipedes, other plants, and insects. Not what you'd expect to find in a slow, gradual process today, but certainly something we'd expect to find if everything happened quickly and abruptly on a global scale. Here's another example that comes out of some shell mines here in the U.S. And this is from Pennsylvania, the Mason Creek, Chicago area. What about the order of fossils? So it's interesting, if you notice that video I played in the previous lesson with those college kids who were explaining why they needed evolution and walked away from the faith. One of them said, well, the thing that convinced him was the fossil record. And it really didn't all the data is a fossil record. And in fact, when I was in college, I took a zoology class with a biology professor. He got up there one day and he said, listen, I know this is conservative, West Texas, a lot of y'all believe the Bible, but here's what you need to know. 98% of all life scientists accept evolution as a fact, and you just need to come to terms with that. And so I thought, wow, this guy is real smart, has a PhD, he studied a lot of birds, he's an ornithologist. Well, I go to his office and talk to him, because I don't agree. And I sat there in his office and I asked him, I said, what is the best evidence of evolution that you could provide? And he said, well, and I'm expecting you to say, look at this bird, and you can see how it's evolved over time. He said, well, it's the geological record. It's all the fossils. I said, that's interesting. You're appealing to a scientific discipline which is not your own. And that's a common theme among scientists. Their own fields usually don't support what they believe, but they like to point to all the other fields that they don't know as well to support what they think. Here's the problem. The most famous paleontologist, Stephen Jay Gould, spent his entire life and career trying to figure out why the fossil record did not support evolution. He was very blunt about it. He said the fossil record, animals appear, then they're gone. Then they reappear, then they're gone. There is no gradual progression that makes any lick of sense to support evolution. That's true. But we have all these nice illustrations and textbooks and models in museums that sometimes make us think that they have this nice progression, but it's not. It's not at all. And so this evolutionary idea of going from invertebrates to fish to amphibians, reptiles, birds, and mammals, well, we do see an overarching theme through the geological column. It's just not one that supports evolution. It actually supports the biblical view. Again, what would be the first animals to be killed off? Well, it would be the ones who are going to be living in the lower parts of the sea level, right? The ones closer to sea level would get killed off first by the waters rising. In the very first rock record, we have what we call the Cambrian explosion. One of those fossils that appears in the Cambrian explosion is this trilobite. And the trilobite just emerges, boom, on the scene, and it has very well-developed eyes, has a very defined exoskeleton. It's a very advanced creature, to use evolutionary terminology. And so it's interesting that we don't see a progression. We just see the animal immediately appearing. Kind of like we expect if a global flood came and killed animals off as you went up into different biomes. And so it's not this evolutionary tree of life like Darwin imagined. Rather, at most, it's like this orchard of all these different animals that will appear, maybe spread a little bit, and they're gone. And then sometimes they reappear. Some of them are still living today. What about dinosaurs? It's interesting, where do we find evidence of dinosaurs or their trackways? Well, they're primarily in the interiors of the continents. What would be the last animals to be killed off by the flood? Those that were the tallest could either swim or have their heads above water. Think about the Brachiosaurus, or what we sometimes call long necks. Well, sauropod dinosaurs, they're the ones that could have been walking the longest, most likely in very wet, muddy terrain, but they would have been some of the last to be killed off. And yet where we find all of their footprints is there in the interior of the North American continent. And so what I believe is a better representation or model to describe this progression is simply the levels at which the sea level in which the different biomes exist. You're going to start in the lowlands, the coastal plains. You'll then move up to more swampy areas, then up to tropical and temperate forest, before you move to the higher elevations where you would kill off the rest of the mammals. And so that's exactly what we see in the fossil record, and I believe it aligns very well with what we see from a flood model. And it also explains the intermixing that we will sometimes see, the displacement or the out-of-order successions that we sometimes see. It explains the overarching theme. Stepping away from fossils, if we look at just the sediments themselves of a deposit, think sandstones and limestones, shales, what we see is that they are deposited very rapidly on very large scale. For example, the Coconino sandstone. This is a very large sandstone with an average thickness of over 300 feet. It covers an area of about 200,000 square miles, touching in Nevada, all the way through parts of Texas, Oklahoma, and Kansas. And the volume of the sand is at least 10,000 cubic miles. Now, this would be a problem because we don't see large bodies of sand like this being deposited today. And so, how are we going to explain this if we are a uniformitarians? Because we don't see water depositing large amounts of sand like this today. Where do we see large amounts of sand like this today? Well, think places like the Sahara Desert. Now, is it a problem from a flood model to have a giant desert in the middle of the flood? Yeah, that would be a huge problem because deserts are windblown, they're dry, they're temperate. I'm saying the entire planet was covered with water. But this proposes an interesting test case. If, as a creationist, I would make the prediction that we do not find these large desert deposits in the rock river, that they're all marine sand deposits. But if that's the case, that would also be in contradiction with the secular model because they would expect sand deposits, because we see sand deposits from desert environments today. So we can apply some tests to these coconino sandstones, which, from the evolutionist perspective, they argue that these are wind-blown desert deposits. And there's 3 lines of evidence here that show us that these are marine. The first is cross-bedding. The second are reptile trackways, and the third is the mineral contents. So if you look at the bedding structure, you'll notice these slanted beds. And those are produced either from wind or water currents. And if you measure the slope of these beds, we can actually determine from a laboratory whether or not they are wind-blown or they're air-blown. And so, excuse me, if they are between 15 and 20 degrees, they're going to be marine. If they're between 30 and 35 degrees, they're going to be desert. And you can even tell, based upon where they're cut off, how high the wave would have had to be to deposit them. And in every case, all of these angles measure for marine deposits, not sand, aeolian or desert deposits. And we can also tell that many of the waves that would have had to produce these sand deposits, this 300-foot thick bed of sand, would have been 60 feet high in some instances. We also have these reptile trackways, which the atheists have used to say, well, this must be evidence that this was a large desert. In fact, I was there in the Grand Canyon last year, and I went to observe this rock that had fallen down from above. And you'll notice that there's a part there that has recently moved and uncovered some new trackways. And I noticed these little dots, so to speak, and I popped one of them out, and this is what I found underneath. I wish I could have brought this with me. I'd love to have had it up here to show it. Unfortunately, it is illegal to remove any rocks from a national park, so I wanted to obey the law. I left it there. But this is interesting because we know of amphibians or lizards to exist in deserts, not in marine settings. And so they said, well, this is evidence that these must have been desert deposits. But what you see is those trackways always go in the same orientation, and they always go up dip, the direction where those sands would have been deposited. And so there was an experiment done. They took some sand, and they put some lizards in it and tried to reproduce trackways. And what they found is if they didn't have water in there were no trackways produced, there was nothing preserved. But if they put a little bit of water, then the trackways are produced and they are preserved. And so the atheists had to come back and say, well, maybe it was the morning dew. Where are you getting morning dew in the middle of a large desert? Also, where are the bodies? We don't ever find the bodies. So in a flood model, they would have been running up trying to escape, but eventually they would have floated up and died. Their bodies would not have been preserved. We would expect them to have been preserved had this been a desert environment. We can also look at the mineralogical content. So I have with me up here 2 minerals. One is quartz, one is mica. You're familiar with quartz. We use this in a lot of glassware, watches, for example, usually made out of quartz. And the reason is quartz is very hard. They will scratch just about anything else, and they're hard to scratch themselves. But mica, on the other hand, very brittle, very easy to scratch, very flaky, easy to break apart. So imagine I were to take those 2, grind them up, put them together in a mixture, and just start tumbling that, say for a year. What do you think would happen after a year? Well, the quartz being hard would totally disintegrate and get rid of all the mica. And so there were some students at Cedarville University, and they formulated an experiment. They took one container, and they added water with quartz and mica, and they ran it for a year, being run through currents. The other one had no water. After a year, there was no mica in the one without any water. But in the one with water, the mica was preserved. because that water created a boundary around those mica minerals that protected the mica. And so this becomes another way for us to test these so-called large desert deposits. If we can find mica preserved, then that tells us they must have been the result of marine deposits, not sand, wind-blown desert deposits. Another example is the Navajo sandstone. This is about a 2,000-foot thick sand, runs all the way from Utah, Idaho, Montana, all the way down to Nevada, even touches parts of Mexico. Huge deposit, has the same layers, cross-bedding, and also has mica content as well. Where do we see huge deposits like this today of this scale at a marine? We simply don't. It's evidence of a global flood. Real quickly, we also see limestone. We know limestones are formed in marine settings, but they're usually thought to form slowly, precipitating, building upwards. Well, the red wall limestone in the Grand Canyon, they have this fossil preserved called a nautiloid. But they're only preserved in about a 7 to 10 foot thick layer that's inside of the red wall limestone. And geologists, creation geologists have mapped out where all these nautiloids are, particularly through the Grand Canyon. And what they noticed is they're all shapes and sizes. There's large adults, there's small juveniles, but they primarily hang out in the middle of that bed. And they go over 200 miles scattered out in this small bed. Well, if you have a limestone that slowly accumulates today, how in the world do you get these millions of nautiloids all killed, all capped in the center of this tiny bed in this large red wall limestone? In fact, some of them are even perpendicular with the bed plane. Well, the way you get them is if you have a large current, and it's scooping up these nautiloids, and it's pulling them up in what we call a turbidite current, and it's preserving them right there in the middle. And it would preserve them in a primary orientation, but you would also have those that are perpendicular. It's exactly what I would expect from a flood, and it shows that limestones can be rapidly deposited, not slow gradual. Okay, a couple more here. I'll just quickly do evidence number 6 here. We see evidence of sandstones that are deposited long distance. That Navajo sandstone that you find in Zion National Park, it has a particular mineral known as a zircon that you can actually use to see the trace where it may have come from. And basically what scientists have concluded is that sand that was deposited out in the Midwest likely came from New York, Canada, from the East Coast to the West Coast. Eroded the East Coast, deposited in the West Coast. We don't see that happening today either. When you look at all of these layers, like if you've ever been driving through a road cut, or if you've been to Grand Canyon, some of those places, what you'll note is those layers are very flat. There's not a lot of things happening in between. Now, we know today that if you just leave a surface barren for a long time, you're eventually going to have some erosion, you're going to have some weathering. I think there's a famous example of this, Old Man on the Mountain. It's on the New Hampshire corridor, famous place in New Hampshire. Some years back, it actually eroded and fell off, no longer there in the same face today. But if you go to somewhere like Grand Canyon, you look at all those bed planes, they're flat. Where is the evidence of time passing between them? There isn't. It's as if they were deposited, and another one was deposited, and another one was deposited. Yet each one of them is supposed to represent millions of years. Why do we see Grand Canyons all throughout the rock record with infill? We will see erosional features from time to time, but that would be expected with a global flood. What would not be expected is what we see from a uniformitarianistic perspective. And it's interesting, I've been out on field trips, both in work and in college, and my fellow students who were taught to think from this uniformitistic mindset, they would never stop and ask these basic questions. Why is everything flat? Where's the passage of time between these? And if you don't stop and think from a standpoint of a younger, you're not going to think some of those questions. Have you ever played with Play-Doh? What happens to Play-Doh if you leave it out for a while, or clay? It dries out, becomes very brittle. You try to bend it or go back to playing with it, it's going to break. And so the only way to really form into those structures is when it's wet. Well, another thing we see in the rock record is the bending and folding of rocks. And we see this on huge scales. We have anticlines and synclines. Anticlines are anthill, that's where they're pointed up like an ant mound. Synclines is when they're inverted. And what we notice in between these rock records that sometimes represent hundreds of millions of years is we don't see them breaking. They're not brittle. Rather, it's a very smooth interface and boundary. In fact, I got to see one. This is up in the Bighorn Basin, up in Wyoming. You look closely there, I'll zoom in on it. A huge, I mean, we're talking probably over 1,000 feet thick. Comes and just totally goes 90 degrees inverts and goes straight down. There is no breaking in the rock. We have shells, sandstones, limestones all mixed in together and are all just immediately turned over basically 90 degrees. How would you do that if they've been sitting out for millions and millions of years, or hard and brittle like they are today? We would expect to see massive fracturing faulting. But that is not what we see. In fact, Andrew Snelling, head geologist at Answers in Genesis, he actually finally had to sue the National Park Service to let him study some of these in the Grand Canyon, just to take a couple of samples because they didn't want him doing creation research. But he's been studying several of these anticlines in the Grand Canyon. I had the privilege last year of traveling with him in the Grand Canyon and looking at some of these uphand. Here's one fold that again is supposed to represent several millions of years. And it goes anticline, syncline, and it actually starts to invert on itself. And I have a video here. There I am sitting next to it for scale. But I went up there and examined it, and there is no fracturing or breaking in the rock, except for what's occurred today from erosion and whatnot. But if you look there, it's a smooth transition. It goes this way straight up 90 degrees. How do you get that? And the idea is millions of years. We don't see that happen today. We also have fossils called polystratofossils. These are fossils that poly meaning many strata layers of rock ascend through multiple layers of rock. Well, are we to believe that rocks or trees just were hanging out for millions of years while the rocks slowly accumulated around them? No, they would have rotted out and something would come along and decompose them over time. So how do these form? Well, we have a good test case scenario from Mount St. Helens. When Mount St. Helens erupted back in 1980, sent a tremendous amount of ash up into the air, but it also sent a ton of debris down the mountainside. Created these large mud flows that ripped up the forest, took all these logs down into Spirit Lake, where they started to rub against each other. The bark would start to come off and settle at the bottom. And eventually, these logs would become waterlogged, and they would actually turn upright. And then they would sink and fall into the sediment as sediment would start to accumulate around them. So we actually have a modern-day laboratory model that explains how we can have all these polystratofossils in the rock record. Evidence number 9. We also see large-scale geologic events. For example, we have bedrock. These are your really hard rocks, your igneous rocks, think granites. And we have at the where the hard rock, the basement rock, meets the sedimentary rock, we call it unconformity. This is one of those boundaries that is very jagged. It looks very different from all the layers above. Here it is in the Grand Canyon. And you'll notice that, the rocks down the bottom look very different from the rocks on the top. The rocks at the top have very flat boundaries versus the rock below, the granites and the schists. In fact, here I am. I have one hand on the sandstone that sits on top of the unconformity. The other hand is on the basement rock that lies below the unconformity, and right there in between is where the unconformity exists. And what you see are these large calcite veins. And there's been huge rip-up clasts, these big chunks of calcite that have been picked up, and they're rolling across the bottom of this boundary. Well, that's what I would expect if there was a massive sand deposit that was put across the country. And we find this sand deposit into peat sandstone. It covers most of North America. In fact, we find the same deposit, we find this unconformity on every continent on the planet today. How do we have this massive worldwide event occurring if things are happening slowly today? As you step up through the rock record, you see similar things all across the world. For example, in the Ordovician, that's right above the Cambrian, we find karsts and carbonate rocks. Karsts are the big sinkholes, cave formations. They're occurring all around the world at this period. You step up above that, you have the Devonian layer, and this is where we define Devonian shales. And according to Dr. Tim Clary's work at ICR, this would have actually been the high point of the flood. Well, the flood would have been coming up receding, like we see waves coming up on the beach today. And if this would have been the high point, which would have then had a lot of things die, particularly a lot of plants and leaves, things that grow, when those have been killed and swept back off, you actually produce shales when you have fast-moving water, and small particles stick together in fast-moving water and then fall out of suspension. And so this coincides with the water coming off the continents at the high point of the flood and filling all of the basins with organic matter. What are the basins of those dimples that would have caught all this organic material? And today, that's where we're drilling all of our oil wells. That's where we're producing all the hydrocarbon, all the fracking, all the unconventional wells that are occurring. We have a lot out there in West Texas. I think y'all have a little bit in southern Mississippi going out to the Gulf of Mexico. Oklahoma, Marietta, Ardmore Basin is another one. We have the Eagle Ford in South Texas. But all these big shale plays that have been a huge boom for the United States, I think make a lot of sense when put into a geological flood context. You also have chalk beds. Now you actually have them here in Mississippi and Louisiana and over in Texas. Most of it's buried. But the ones you've probably seen images of occur over in Europe. The White Cliffs of Dover, these huge white chalk beds. Well, these are actually found pretty much on every continent worldwide. How did we get those? Makes sense if we have a global flood. You also see volcanic activity all around the world. This is what I spent my graduate research on, was mapping one of these huge volcanic provinces. The one I mapped is about 1,000 miles off the coast of Japan. It's called the Shatsky Rise. It's about the size of California. The one volcano that I was really focused on mapping was Tambi Massif, which that one volcano by itself is about the size of New Mexico, the entire state. So imagine all these volcanoes going off around the same time. The amount of tsunamis, the amount of upheaval that would have produced, the amount of ash that would have been put into the air, that eventually is what would have sent our globe into an ice age. Last year, this wasn't well reported, but there was a volcano that exploded in the Pacific Ocean. It was an underwater volcano, so I wasn't reported on because there wasn't a whole lot to say about it. But it sent a ton of water vapor up into the atmosphere. Well, if you recall, all the talk for climate change, last winter there was a lot of concern in Europe for Europe having a cold winter, not having enough natural gas, and Russia being able to take advantage of that. But they had an unusually warm winter. Also notice the news is making sure to let us know we had an unusually warm summer this last summer. Well, how did greenhouse gases work? The number one greenhouse gas is actually water vapor. So you throw that water vapor up, it captures the sunlight, and it creates the greenhouse effect. But they didn't want to connect that with that large volcano going off last year. Difference though, like with Mount St. Helens, when it went off, that was a land volcano. And a land volcano sends aerosols up into the atmosphere. I wasn't alive in 1980, but I've talked to people who were, and they said when that happened, it lowered the temperature in places like Texas, and I presume here as well, by some 15, maybe 20 degrees, shortly after all those aerosols coming down other parts of the country. But again, we see this happening on a global scale in the geological record. Dr. Tim Clary has been mapping these sequences of rocks that stick together. And what you see are these are all marine deposits that have residuals, leftovers, things that haven't been eroded away, and they're in all parts of the continent. Same argument made with the fossils. We see marine deposited rocks scattered all throughout the continents. the high points, the low points, and the interiors. Last evidence, evidence number 10, catastrophic plate tectonics. I'm sure you've heard of plate tectonics, the idea of Pangea, the once supercontinent, where all the continents fit together like a puzzle piece. Well, again, if we start with Genesis 7:11 reads, "In the 600th year of Noah's life, in the second month, the 17th day of the month, on that day all the fountains of the great deep were broken up, the windows of heaven were opened." Genesis 8, verse 2, "The fountains of the deep and the windows of heaven were stopped, and the rain from heaven was restrained." And so what plate tectonics teaches is all the continents used to be together, and they're still moving today, but they're only moving, a couple of inches per year at most. This is evidence it took a really long time for the continents to get where they're at today. The catastrophic plate tectonics asks the question, what if they didn't move slow? What if they had moved fast? Would there be evidence to support that? And so one of the scientists used to be at ICR, he did some modeling, used a supercomputer, and what he saw when he saw the conservation energy equations is that if I take a really cold surface plate and I submerge it into hot molten magma underneath the plate, I get a runaway pulling effect, where it actually will pull that plate down underneath the plate that sits on top. And since that time, since those predictions, we've been able to use seismology to map the underneath the continents. And so we've actually mapped that across the United States. And you'll notice that out in the Pacific Ocean, we have the Pacific Plate, and it subducts underneath California into the North American Plate. And we can actually see that plate being subducted underneath the United States today. And the reason we can see it is because it's still cold material. How do you take cold material and subduct it into really hot material for millions and millions of years, and it doesn't heat up to match the surrounding material? That's also how we get the plates moving away very fast during Noah's flood, also contributing to all the tsunami of getting the water up on top of the continents. So there's 10 evidences for a global flood. Again, if we start with a biblical basis and then approach the evidence, I believe the evidence clearly supports a global flood. And if you want to study more, make sure you get a USB stick. There's several additional books and resources you can dive into to learn more about that. Take about a 10-15 minute break, and then we'll come back and talk about some historical evidence for the flood and Tower of Babel.